Hello everyone, welcome to Cynohub. So in today's session, we are going to see about the different forms of ADC, that is analog to digital circuits. As we know that in the point of communication, we are coming across this concept of converting an analog signal to a digital signal. So in the process of analog to digital, there are several sort of techniques which are used, but through the process of an operational amplifier, so we are going to see different forms of an operational amplifier related circuit to convert, how we can convert an analog signal into a digital data process. So in this point of view, the first kind of an type of circuit which will be we will be calling it as the that is flash type ADC. Okay, this is flash type ADC, which we are also going to name it as, we can also call it as the parallel type ADC. Okay, so this is the first method, and second way we can consider it as the counter type ADC. Okay, second method will be called as the counter type ADC. Okay, so and there is also one more term which is called as a successive approximation type ADC. Okay, so successive approximation is also another type of representation that what we can relate through this, and all these things are relatedly going to be represented in the way of how the circuit representation is different. So here we see the ideology of flash type and as well as the counter type related ADC, and we can go with the solution of one of the problem with respect to the successive type ADC method. Okay, so coming with the first one, so here we are going to see this is our flash type ADC. Okay, flash type ADC, or we can also call it as the parallel way of ADC, parallel type. So where we can see that how many number of comparators are going to be used and how many number of matched resistors are used, because here we can see, suppose if here we are going to take 3-bit, okay, 3-bit flash. If you consider 3-bit flash type, then in the 3-bit flash type we can take 2 power 3. Okay, so generally 2 power 3. So 2 power 3 represents what? 8. So 2 power n, that is n value is 3 now. Suppose if I take 3-bit type, if you take 4-bit type, then it will be n value will be 4. Okay, if you take 2 power n, then 8. So in total, we can say that we are having 8 resistors. Suppose you can take R1, R2, R3, R4, R5, like that you go on representing total 8 resistors. And for a 3-bit flash type, so we are going to have how many comparators? That is 2 power n minus 1. Our n value is 3. 2 power 3 minus 1, that is 7. So total how many comparators? 7 comparators. So this is 1, 2, 3, 4, 5, 6, 7. Okay, total 7 comparators are going to be used. And the responses of this comparator, we are going to apply for a priority encoder. Okay, so priority encoder will relate. So on what particular type of an input related data we got, that it will take the priority and then it is going to provide the output response. Okay, so for a 3-bit flash type, we are having 7 comparators and 8 matched resistors. Okay, here how the operation is going to be carried out in this particular term, in the sense, suppose if the first voltage is at active mode. Okay, first if the first comparator is associated for the first input voltage, we provided the input voltage here, Vn. If we receive the first one, if you relate the first one, then this signal is followed and remaining all are in disable mode. Means all these comparator connections are removed. Then what happens? First we will be receiving, then first output is received from the comparator 1. And remaining all terms will be going to be 0. Then what happens? So we will be taking the priority encoder point of view. So just we will be considering the responses in terms of 7-bit conditions here. Suppose we can take the response in terms of, let us take, suppose if I am having total 7. Okay, right? So I will be taking I7, I6, I5, I4, I3, I2, I1 and I0. Okay. So in this, first if this first one, I1 value, if it is at the point of this 7 comparating point of view, suppose if I take this first I6 to I0, okay, or else I7 to I1, we can take anything. Suppose if the first one is at high potential, means input is applied for this first comparator, then this will be at highest potential. Okay, that we can take it as an highest potential value. Remaining will be taking it as a 0. This is at highest potential. Means you can take it as 1. If the second one is active, this I1 is at active, remaining all we can take it as zeros. If third one is active, third one is 1, remaining all we are going to take it as a zeros. Then what happens when you come across B0, B1, B2 values, at that point of view, the point of the which condition, priority encoding condition, which one is higher, first we will be getting, in the first case all are zeros. In second case one value is high. That is because our I0 is high. In third case, 2 values as high. 2 values represents 1, 0. In third case, 4 values as high or 3 values as high. Then 0, 1, 1. Next 1, 0, 0. Next 1, 1, 1. Next 1, 0, 1. Like that we will be taking all 7 will be active at that instant. Means B0, B1, B2 will start from 0, 0, 0 to end up to 1, 1, 1 point of. And remaining all the values of this priority encoder, we will be taking it as the point of 3 by 8 priority encoder. Okay, so this 8 inputs what you can take, I7 to I0 you can take, and we can make whenever first is active, I0 will be 1, remaining all zeros. When second one is active, I1 will be 1, remaining all zeros. Third one, I2 will be 1, remaining all will be zeros. Like that it will process, and when all are zeros, this will be 0. First, if any one bit is high, then this value will be becoming 1. Next it will be 2. Next it will be 3. Like that, which comparator response is providing the input signal, then that particular comparating, it is going to relate it as the responsible output. Okay, so this is the way of representing or converting the process of input data. This is based on the input data. Okay, input data we are applying, and this comparison point of view, this comparator will compare. If an input data is becoming high with respect to the reference voltage, then this will become active. When it is active, then this will be value is high, remaining all will be low. Like that we are going to check. Sometimes all will be active, then at that moment it will be providing the result as 7. If any one is active and remaining 2 are non-active, then based on the representation, it is going to provide you the response in terms of an either digital data from analog to digital conversion process. So this is an operation in terms of an flash type ADC. So in the coming session, we see across the concept of counter type ADC. Thank you.